here I have a function on two variables that in a previous video we actually already took the partial with respect to y. Here I've taken the partial with respect to x. You can pause the video here and check to make sure I've done that correctly. One thing I notice right away is that the partial with respect to x is a function on both x and y. The partial with respect to y is also a function on both x and y, which means I should be able to take another set of partials. I should be able to take the partial with respect to x of the partial of f with respect to x. Notationally, this is a second partial. And I could write it down like this. So now I need to do it. This part would be treated like a constant, so I just get 6x. Over here, same line of thinking, I get the partial squared f over partial y squared, the second partial with respect to y. Minus 9x is a constant, and I get 6 times y. And so here I have what I call second partial derivatives. But I'm not done yet. Here, I took a partial with respect to x, and then I took the partial with respect to x again. But if I look at that same partial, I could also take its partial with respect to y. Notationally, I would be taking the partial with respect to y of a partial derivative. So on top, I could think about using the partial squared notation, but on the bottom, I would have the partial with respect to x and then the partial with respect to y, and I have to realize that I'm reading this from the inside out. The partial with respect to x happened first, and then the partial with respect to y. All right, well, here was my partial with respect to x. I just copied it over again, and now I need to take its partial with respect to y, and I get minus 9. This is a second partial with respect to x. This is a second mixed partial. I need to do the same thing here. I should be able to take that and also take a mixed partial. I'm going to give myself some room to work here. So it would be a second partial with respect to y and then x. All right, so I start here and I need to take a partial now with respect to x, and I get minus 9. Hey, that's cool. The second mixed partials match. I wonder if that happens a lot. Okay, so there are my second mixed partials. I think you could imagine third partials and fourth partials and all kinds of combinations of partials that all could happen in some kind of order. But here at the end of this video, instead of taking more higher order partials, I actually want to talk about notation, because there are two different notations for partials. If I have a function z equals f of xy, it's appropriate to call a partial with respect to x either partial f with respect to x or partial z with respect to x, right? Because z equals, it's like saying dy dx or df dx. Nothing very interesting there. The real other notation is to say, hey, I can take a partial with respect to x, or I can write it like this, right? This is f, take a partial with respect to x. Okay, and then I could have a partial with respect to y. Where the notation, so this is kind of like the prime notation, right? You put a prime on there, it's called a derivative. Now we're just using subscripts because we need to tell our reader what derivative we're working on, right? Is it a partial with respect to x or with respect to y? If I take a second partial or a mixed partial, I have to be very careful with my notation. This says first take the partial with respect to x and then with respect to y. In this notation, I go from the inside out. In this notation, I go still from the inside out, acting on f, right? F, I take the derivative, partial derivative with respect to x, and then y. So we have to be careful. The two notations don't get read from left to right, right? They get read from the inside out. And just for note, then this would be fyx. So the second mixed partials we have to be careful about. And just one more example using that notation so that we can make sure we understand it completely. If someone asked me to take the third partial f x x y, let's see, that's a third partial of f first with respect to x, and that actually happens twice, and then with respect to y. You know, I said one more example. Let's just go on and do one more. Let's talk about what fyy(x(y) would look like. So that is a 1, 2, 3, 4, fifth partial of f. First with respect to y twice, and then x twice, and then finally with respect to y again. Always reading from the inside out. And that's the other notation for the partial derivative.